Welcome to the next lab session on generative AI. So the next we are going to discuss about the second lab program. So the program 2 says use the dimensionality reduction. That is, we can use either PCA or TSNE to visualize the word embeddings. First, you have to select 10 words from a specific domain. So we can take the domains like sports or technology and visualize their embeddings. Analyze the clusters and the relationship, generate the contextually rich output using the embeddings. So write a program to generate 5 semantically similar words for a given input. So we have to first do the dimensionality reduction, and then we have to find out the 5 semantically similar words for the 10 selected words from the main domains of sports or technologies. So first we will see what are these word embeddings. So as you already know, so word embeddings are nothing but it is the vector representations of the words. So for each of the word we have the vector representation. So that is what we call it as the word embeddings. So it is mainly used to find out the semantically similar words for any of the given words. So the popular pre-trained models for using this word embeddings includes the word2vec model as well as the Glove model. So the Word2Vec model, so it is mainly trained on the large text corpus, which is mainly using a neural network. And Glove model, that is the global vectors. So it is mainly used for the vector representation that is mainly based on the matrix factorization. So for all the calculations using the matrix, so that is how we are going to find out the vector values in the Glove model. And then one more we have is the fast text, which is mainly extends the Word2Vec model by mainly representing the words in the ng grams characters. So what is this dimensionality reductions? So dimensionality reduction is, as I told, so for each of the word, there will be different dimensions. Like if you are using a 50 dimensional model, it will be having 50 dimensions. 100 dimensional model, it is be having 100 dimensions. So we can't represent or we can't visualize all the 50 or 100 dimensions on the screen. So for that reason, what we do is we reduce from the 50 dimension or 100 dimensions to a 2D or 3D dimensions, so that it will be easy to visualize the similarities or visualize the words. So in order to that, we are going to perform this dimensionality reductions. So for this, we can make use of two main dimensionality reduction techniques. One is PCA, that is principal component analysis. So which is mainly a linear technique that projects data onto the orthogonal axis. And one more is the TSNE, that is T distributed stochastic neighbor embedding. So this is a non-linear technique which mainly preserves the local relationships between the points. Next, we have to find out the similar words. So what is this semantically similar? So this is mainly performs the cosine similarity, that is the cosine index. So by calculating the dot matrix or the dot product between the two words, dividing by the length of the each word. So whatever the value we get, so that is the cosine product. So using this cosine value, we are going to find out the semantically similar words for any of the word which are given as the input. So now let's see what is this program about. So this is the experiment 2, that is by using the dimensionality reduction. So we have to find out the semantically similar words. So first we want the NumPy. So because we are going to plot the values, we are going to use the graphs, so all those the calculations, mathematical calculations. So we make use of the NumPy, that is importing NumPy. Next, Matplotlib in order to plot the graph. Next, I'm going to use the package sklearn. From that, I'm going to import PCA. So we can either import PCA or TSNE because we are using any one of the method. Here in this program, I'm mainly using PCA, so only this can be imported. So keyed vectors, as we have already discussed, it is mainly used for mapping of the words to its equivalent vector values. So in order to have this key value pair mapping, so we make use of the keyed vectors. I'm using the 100 dimensional model, the Glove model. So I'm using the keyed vectors and I'm mapping the words into its vector forms and storing into the variable called as model 100D. So here I'm giving the binary as false because the values which are taken as input is all the text values, that is a natural language processing values. So that is why the binary values are given as 0. So it is given as false. Next, you have to specify some 10 words from a particular domain. So as it's mentioned in the problem statement. So we are taking the 10 words from the technology as well as the sports. So all these are related to the sports and these two words are related to the technologies. So now we are going to use the NP array in order to read each words from the words and calculate its vector values and store it in the word vectors. So np.array mainly helps in reading each words from this array and storing it into the word vectors, that is the vector forms for each of the words. Next, we are using the PCA in order to perform the dimensionality reduction. So here n component specifies how many dimensions we want. So if I specify 2, it will be reduced from 100 to 2. If I specify 3, it will be reduced from 100 to 3 dimensions. So PCA of n components mainly reduces the dimensionality. Next, the fit transforms. So I'm going to pass all the values which are there in the word vectors. So it is going to transform each of the word from 100 dimension to the 2 dimension and it will store it in the variable called as PCA result. Next, I'm using the scatter in order to use, that is the scatter graph. It is being used in order to map all the values. Next, I'm using the title, that is PCA visualization. So this is the title of my graph. Next, X label and Y label. So X label gives the words and Y label gives the vector values for each of the word that is being used. And then we are going to show the values. Next, we have the get similar words. So for each of the words, so what are the similar words? That is the top 5 similar words need to be extracted. So I'm going to return it. So this is a function that is get similar words. So I'm passing the word as well as my model, that is we are using the 100-dimensional model, and I'm specifying how many number of top values I want. So here I'm specifying top 5 values. So this is the function, then it is going to return the value. So once I'm going to pass the word and the model, then it is going to print the top 5 similar words for this particular word specified. So here I'm passing the word football. So the top 5 similar words, the vector values of the words football, so that will be printed. So before that, we can see the graph that is plotted for each of the words, the 10 words which we have taken. So all these are the words related to sports and these two are for the technology. So we can see that these two words are far apart from the remaining words because it is having more distance in the vector value. So it has been far compared to all the other words which are more similar to each other because they have the vector values very much similar to each other. So they are very much nearer. So these two words having the vector values which have greater distance between the two values. So it is far when compared to the other values. So here we can see the top 5 similar words that has been displayed for the word football. So saucer, basketball, league, rugby. So these are the 5 top values that have been printed for the input word football. So the similar words are being calculated using the cosine similarity and it is going to be printed. Next, we are going to select a few words that is which we want to print and then I'm going to print the vector embeddings for the word which we have specified and then we are going to say whether that word is found in the embeddings or not. So if the word specified here, it is there in the embeddings, it is going to print its equivalent vector values. If the word is not found, then it is going to print the word is not found in the embedding model. So here I'm specified two words, memo and saucer. So the vector value, so we can see here all the 100-dimensional values are printed. So like this, for each of the word, there will be 100-dimensional values. So these 100-dimensional values are reduced to 2-dimensional by using this PCA PCA value. So with the help of the PCA technique, we can reduce from such 100 dimension to 2 dimensions so that it will be easy for the visualization. So all these are mapped with the help of the 2-dimensional values. So with the help of PCA, now we have calculated all the dimensions, 2 dimensions, and it is printed here. So if it is 100 dimensions, it will be printed in this manner. All the 100 dimensional values will be printed. So these are the vector values for the word memo as well as saucer. So like this, for each of the word, it will be having its own vector values. So this is about the program 2. Thank you.